Find the vertex of y equals to negative 3x squared plus 4x minus 9. Alright, so now from the when it's arranged this way in descending powers, then A is going to be negative 3, B is positive 4, and C is negative 9. Now those are the same constants that we used in the quadratic formula, A, B, and C. Well, our x-coordinate of the vertex is minus b over 2a, based on what I just did. So if I plug these numbers in, and I get negative 4 over 2 times negative 3. And let's see what we get here. The negatives cancel. I get 4 over 6, which is 2/3. Always reduce your fraction when you can. So that tells me where the middle of the graph is of this parabola, or where the x-coordinate will be of the vertex. And now to find the y vertex point, then I'm going to plug that number into the function. So if I do y of 2/3, and by the way, this is sort of another way of writing f of 2/3. Y is a function of x. You could write y of x instead of f of x. It's not all that common to do it that way, but it works. So the y value when x is 2/3, I plug it into here, negative 3 times 2/3 squared plus 4 times 2/3 minus 9. Let's see, a little bit of arithmetic here. Negative 3 times 4/9 plus 8/3 minus 9. And let's see, is that right? Yeah, it looks like it's right. The 3 cancels with the 9 here. We may as well do that. So I have minus 4/3 plus 8/3. So minus 4/3 plus 8/3 is positive 4/3. And 9, let's get our common denominator. 9 will be 27/3. So we end up with negative 23/3. All right. So a little bit of work there to get the y value, but now we know what the vertex is, and I don't know where to write it, do I? So I'll have to make a little room here and write that out. And I like you to communicate in plain English. So if I ask you where the vertex is, please tell me. Don't grunt it to me. Don't just put 2/3, negative 23/3. Put the vertex is at, and this will be the point x was 2/3 and the y value was negative 23/3. There we go. So there it is. Now another question I might raise here is this the maximum or the minimum of the function? And because it has a negative leading coefficient, then the parabola has been reflected around the x-axis. It means it's an upside down parabola. So the maximum of the function will come from the vertex. Here's the maximum up there. So let me just write that as well. The maximum is y equals to negative 23/3. All right. So in case I was asked, and it will be from time to time, to identify whether your function has a maximum or a minimum, and tell us what it is. All right, so I'll do one more example. Here's our example. Determine the maximum or minimum of f of x equals to 2x squared plus 5x plus 1. Now, will it be a maximum or a minimum that we're finding? Okay, it's got to be a minimum because the leading coefficient is positive, so the function points upwards, which means it bottoms out and at a minimum. So that we can tell immediately just by looking at the leading coefficient. That leading coefficient really plays a pretty significant role on how functions behave, in particular polynomial functions. And so we'll see more and more of that as we move through this chapter. Anyway, the A would be 2, B is 5, and C is 1. I really don't need C because my little formula we derived for finding the vertex doesn't use C. It just uses B and A. So when I plug these numbers in, I get minus 5 over 2 times 2, which is minus 5/4. So there's the x-coordinate of the vertex, but the maximum or minimum of the function is in reference to the y value. How high or how low does it go? So we have to calculate the y value, and f of minus 5/4, let's plug that in. So we've got 2 times negative 5/4 squared plus 5 times negative 5/4 plus 1. And let's see, we'll work through this. This is going to be 25/16. 25/16 times 2 will be 50/16. Minus, here I have 5 times negative 5, so it's minus 25/4 plus 1. Let's see. Well, I'm going to have to do what? This will be 25/8. It's 25/4. So I'm going to have to go to a common denominator of 8 here. So I'm going to reduce this fraction down to 25/8 and make this 50/8 to get the common denominator. So it's minus 50/8. And then the 1, if I go to 8s, then it has to be plus 8/8. And by the way, we seem to notice this a lot. When you plug these numbers in, it looks like this number is half of that number, and are they opposite signs? I think they are. Anyway, it seems to be a pattern that you see on these quadratic functions. So I've never really explored it much, but it seems to crop up a lot. That turns out that one of these is always half of the other at the vertex only. Well, anyway, let's move on. So let's see, 25 plus 8 is 33. 33 minus 50 is negative 17. So this is equal to negative 17/8. All right. By the way, no matter what sign you get for this, if it's a positive or a negative for your y value, that itself has nothing to do with maximum or minimum. It's the shape of the graph. And so you could have a maximum of a function at a very small negative value, for example. And so the sign here has nothing to do with maximum or minimum again. It's the sign of the leading coefficient that determines that. Well, I'm going to write my answer, so I need to make room here. And let's see. Uh-oh, I forgot my x value. It was 5/4, I think. Let's see, minus b over 2a. It was negative 5/4. Okay. All right, so the minimum is negative 17/8 when x equals to minus 5/4. Period. All right. So that, to me, this is a pretty full answer. We stated the minimum, even told where to find it. So basically, I wrote where the vertex is. All right. So that's going to come in pretty handy in applications that we're going to see in this section. And because when a word problem or application is simple enough to express in terms of a quadratic formula, a quadratic function, then we can optimize it. We can find its maximum or minimum values. So we'll move on from here.